Hello, my name is Derek Freeman. My article presentation will be on the nutritional habits among high-performance endurance athletes. The objective of this study was to have a better understanding of high-performance endurance Lithuanian athletes. The aim of the study was to determine the habits of the highly trained endurance athletes depending on sports type, sex, and age, in order to improve planning and management of training of athletes using targeted measures. In 2009 through 2012, the dietary habits of 146 endurance athletes were analyzed. At the end of the study, it was found that 80.8% of endurance athletes used lower than recommended amounts of carbohydrates in their diet, and more than 70% of athletes used higher than recommended levels of fat, saturated fatty acids, and cholesterol. Authors used multiple means of reference for this study. These three in particular were used by the authors to help create a baseline of training needs, nutritional recommendations, and gender-specific nutritional intakes for each of the athletes. The main issue being addressed by this study was, are Lithuanian endurance athletes ingesting enough macronutrients to compensate for the amount of intense workload being placed on their bodies? Researchers also wanted to identify and determine the actual nutritional habits of high-performance endurance athletes, depending on sport, sex, and age. The study population was combined of athletes from years 2009 through 2012. 146 athletes were chosen, all of which that participated in high-performance endurance Olympic-style disciplines. These athletes were tested during a preliminary period before competition. The scope of the athletes' workload fully complied with the approved training plans set forth by the standards. Athletes were later then assessed by training plans that were based for highly skilled endurance athletes training for the Olympic Games. Once athletes were chosen for the study, standard measurements were then taken at the beginning of the assessment of each athlete. Athletes' BMI were then calculated using standard measurements for the BMI. Each athlete's height and weight was taken and then divided to get an accurate BMI for a starting point for each athlete. Standard ranges applied for the BMI, checking athletes for excess weight, obesity, normal body weight, and underbody weight. Muscle and fat mass index of athlete was also assessed according to current standards. The actual diet of Lithuanian endurance training athletes was investigated using a 24-hour dietary survey method. The survey was performed by a trained interviewer using the direct method. In the course of the interview, food recall, the portion sizes, were also gathered. To assist in accurate portion size, atlas of foodstuffs and dishes were used. The atlas displays different portions of products and meals assessed in grams, making it possible to record the amounts of all food products and meals consumed. The average daily food intake of athletes was evaluated, and the chemical composition and energy value of the food ratios was determined using chemical composition tables. Macronutrients, carbohydrates, protein, and fat intake were assessed according to recommendations in other academic literature used as a baseline. Energy requirements for each athlete were calculated using standard formulas such as the basal metabolic rate, daily energy expenditure, and training energy expenditure. the metabolic equivalent rate, MET, were used with an understood work to standard rest ratio of 1.0. 24-hour records of physical activity were collected on the same day that participants recorded their dietary intakes. Participants recorded a 24-hour period, frequency, and duration of different activities expressed by the rate of energy expenditure for each activity were estimated. The physical activity level, POW, of all athletes was calculated as a ratio between daily energy expenditure and basal metabolic rate. To estimate the total energy requirement, the basal metabolic rate was then multiplied by the appropriate activity factor. Statistical data analysis was carried out using up-to-date statistical software. Conventional methods of descriptive statistics were applied for analysis of research data as well. This first table is a breakdown of each individual endurance athlete's sport, broken down by the days of exercise per month, exercises per month, total physical workload hour per month, total physical preparation hours per month, and total physical training hours per month. Each stage is broken down month by month and sport by sport. Table number 2 is a breakdown of body fat and the muscle fat index for each of the athletes. These standards were set for both male and female. These charts helped researchers to better understand athletes' beginning levels, whether it be too low or too high, and the adaptations that they make during the actual training, if they're losing too much muscle mass, too much body weight, etc. This table shows the characteristics of body weight, height, and body mass components of endurance athletes by sport type and gender. At the evaluation of the data, all athletes' body composition by sport and sex showed that the BMI of all athletes was within normal range. Body composition indicators show that regardless of gender and sport, lean body mass of athletes fell within normal limits. This table describes the estimated energy requirement and energy intake of athletes involved in different sports. In almost 78% of athletes, energy intake did not fully cover the energy expenditure that athletes were doing. Through this research, researchers found that energy intake is too low, is very specific to long distance runners, rowers, swimmers, skiers, and other cyclists. This table shows the macronutrient breakdowns of carbohydrates, protein, and fat levels consumed by athletes. At the end of the study, researchers found that athletes used less than recommended amounts of carbohydrates, omega-6 fats, omega-3 fats, and dietary fiber. At the same time, they consumed too much fat, cholesterol, and protein. Through this research, researchers proved that athletes did not optimally supply their bodies with vitamins and minerals in food. This chart shows the breakdown of vitamins and minerals consumed by each of the individual athletes in their sport. Through this study, researchers found that female athletes, more often than male athletes, consume quantities of vitamins and macronutrients lower than the recommended daily intake of vitamins. According to age, it was found that older athletes were more likely than younger athletes to use quantities of vitamins folic acid lower than recommended daily amount. Meanwhile, in ages 14 to 18, more often than 19 to 31-year-old athletes consume quantities of B vitamins, phosphorus, and magnesium lower than recommended daily intake. Researchers evaluated data and came to the conclusion that body composition of athletes by sport and sex showed that body mass index and both lean body mass of all athletes varied within normal range. Researchers found that no athlete in the study suffered from having less fat mass that was too low. The body composition of male athletes fully complies with the requirements set forth in standards that were used by the researchers. Female athletes were assessed as optimal to sufficient, but their muscle to fat mass index was assessed as moderate and did not completely meet the requirements for the body composition of elite athletes. Since carbohydrates is the main source of energy for endurance athletes, researchers found that the carbohydrate intake should be relatively 7 to 12 kilograms per body weight. Through this research, researchers found that the average carbohydrate consumption of a Lithuanian endurance athlete was only 5.6 kilograms of body weight. Researchers also noticed that highly trained Lithuanian swimmers consume more carbohydrates than athletes in other countries, while cyclists and long-distance runners in Lithuania consume fewer carbohydrates than endurance athletes in other countries. Even with these numbers, compliance with recommended carbohydrate consumption was found only among endurance athletes in South Africa, Spain, Australia, and Poland. Protein deficiencies are rarely found in the diet of many endurance athletes in other countries. Conflicting results showing that as many as 1/3 of Lithuanian endurance athletes use less than the recommended amount of protein. Researchers also found that protein intake depends on gender and age of the endurance athlete. Male athletes aged 14 to 18 consume more than the recommended protein content, while female athletes consume frequently below recommended levels. Excessive dietary intake of fat in Lithuanian endurance athletes ranked up around 70%. The consumption of fat, cholesterol, and SFA is higher than the recommended. Athletes participating in rowing and long-distance running consume the most fat. In closing, researchers concluded that 1/3 of Lithuanian endurance athletes did not get the recommended amount of protein, and 80% did not consume sufficient carbohydrates within their meals to support the workloads that they were applying to their body. Excessive fat intake leads to excessive saturated fatty acids and cholesterol in the diet of endurance athletes. Nutritional profiles of athletes was more determined by gender and age than by sports type. Special attention should be given to female athletes because of quantities of carbohydrates, dietary fiber, protein, omega fatty acids, B vitamins, and other vitamins and minerals that were low in their diets. Researchers concluded that Lithuanian high-performance endurance athletes do not meet the nutritional recommendations and thus can adapt to large-scale, long-term endurance exercise. The diet of highly trained endurance athletes must be optimized, adjusted, and individualized. The main purpose of nutrition is to ensure the compensation of increased energy consumption and the need for nutrients in the athlete's body, therefore enabling maximum adaptation to the physical loads placed upon their bodies